morning, everyone. It's 8 o'clock. It's 3 minutes past the hour of 8 Vietnam time. Good morning, good afternoon, good evening for all who are attending this second technical session of the first AIT, Global AITAA Symposium and Exhibition. So President Fe Ferriols of the AIT Alumni Association, distinguished speakers and delegates and participants to this technical symposium. Yesterday, we had the first session on energy, environment, and climate change, where we have drawn 6 distinguished speakers. And I would like to mention, the topics that were discussed by our distinguished lecturers. Professor Joyashri Roy spoke on the 21st century economy, climate, energy, and social transformations, a global South perspective. The second speaker, Mr. Ha Dang Son, talked about moving towards a carbon neutral roadmap for energy systems, impact-based multi-hazards early warning system, for energy systems. The third speaker, Dr. Bapon Fakhruddin, talked about the impact-based multi-hazards early warning system Pacific perspective. It was actually chaired by Professor Shobakar Dakal. The second parallel session yesterday was chaired by Professor Sankar Bhattacharya, and we also had 3 speakers. Professor Sahadat Hussain talked about a roadmap for sustainable waste management in developing countries, while Professor Animesh Dutta spoke on an integrated, tunable, and closed-loop circular economy approach for bio-waste valorization. And the third speaker, Dr. Priyantha Wijayatunga, spoke on the future energy sector financing, a multilateral development bank's perspectives. We had an engaging plenary discussion yesterday where 2 of the panelists were actively engaged, Professor Chetpan Visvanathan and Dr. Brahmananda Mohanty. So it closed actually at 5:30 yesterday with a very positive result on the discussion on energy, environment, and climate change. So today we open the second technical session where we have also 3 distinguished speakers and 2 panelists. This particular session would be chaired and moderated by Professor G.S. Wu. Professor Wu is a professor at the University of North Carolina at Charlotte, where he serves as director for the interdisciplinary doctoral program in infrastructure and environmental systems. He is a graduate of National Taiwan University, Asian Institute of Technology, and the Rutgers State University of New Jersey, and a registered professional engineer. In his early career, he engaged in water treatment and industrial water pollution prevention studies, followed by his contribution to highway runoff control and management. For the last 10 years, he has been teaching graduate courses in renewable energy and energy systems engineering and directing research in energy markets and their environmental impacts with research collaborators in energy economics and policy. Professor Wu has received numerous research awards from federal and state agencies as well as industrial sponsors. He was a Fulbright Scholar and chair of New Technology to Southeast Asia. He was invited by the United Nations as a speaker in several workshops held in the US and overseas, and has lectured to the Taiwan Environmental Protection Administration and city governments in Taiwan on emerging environmental issues. Professor Wu has directed more than 70 master's and over 15 doctoral graduates. To chair this particular session on agriculture, food, and water, ladies and gentlemen, Professor G.S. Wu. Professor Wu, the floor, please. Thank you.
Thank you for the introduction. Ladies and gentlemen, good morning, good afternoon, good evening. Yesterday, I participated in a few sections. The things that I learned most was the curve that the developed country has gone through to go up and then down, but then other countries can go a shorter path. So that's a very interesting concept that I learned a lot yesterday. So today, we have this first global symposium on sustainable technology innovations. We have three distinguished speakers who will go more into details of the presentation. The three speakers are Dr. Leo Anduan and Dr. Ajay Praham and Dr. Victor Marco Ferrells. And then we have two other panelists, which is Harry Kasuma Aliwata. And then we have Dr. Haya Ula. So these are very excellent individuals making contribution in various aspects. We will have the presentation display showing through videos. And if you have any questions or comments, please submit it through the chat so that I would watch it, and then I'll try to read out those questions at the end of the presentation. And then we will have the speakers to respond to your questions. Now, our first speaker is Professor Neil Antuan, and Dr. Tuan is currently a senior lecturer of the College of Environment and Natural Resources as scientific advisor for the Research Institute for Climate Change, Cantor University in Vietnam. Dr. Tuan completed his bachelor in water management and land improvement at Cantor University in 1982, and his master's in water resources engineering from AITAA in 1990. He finished his PhD in applied biosciences and engineering, specializing in environmental hydrology at Catholic University at Louvain, Belgium. In 2012, Dr. Tuan was officially recognized as an associate professor in earth sciences in Cantor University. So with that introductions, let's welcome Professor Tuan's presentation. Can we have that video on? Thank you.
Ladies and gentlemen, greetings from Vietnam. First of all, I would like to thank AITAA for organizing this workshop and allow me to present the topic Challenger for Sustainable Development in the Mekong River Delta, Climate Change, Water Resources, and Food Security. This is an issue that the Mekong people must pay attention, and also it is a great challenge in the context of the increased demand for more food, while the water resources of the region are degrading and facing many risks of the climate change, as well as the new disease as the COVID-19 pandemic. Today, I would like to present 4 parts as the content is screen. First, status of the agricultural farming in the Mekong Delta. Second, agricultural innovation policy in Vietnam. The third, some applicable smart agricultural innovation idea. And the fourth, discussion. As we all know, the traditional agricultural production in any countries is highly dependent on the climate condition and water resources. In our lower Mekong region, there are only two seasons, the rainy season and the dry season. The rainy season lasts 5 months from May or October, and the dry season is the last of the remaining 7 months of the years. The main feature that in the rainy season are also the flood season, and we found that the average discharge of the Mekong River during the flood season is very large, about 39,000 cubic meters per second. While in the dry season, the water is low and a saline intrusion from the sea coming into the 1/3 of the delta area. And we also found that in the dry season, the flow from the upstream to the delta dropped dramatically to 2,500 cubic meters per second in average. In the Mekong Delta in Vietnam, we consider as the biggest agricultural aquaculture production in Vietnam. Almost the water from the Lan-Can Mekong Basin come to the Mekong Delta before entering the East Sea. The Delta had 2.4 million hectares of the agricultural land, over 4 million hectares of the total area. Every year, the Delta supply more than 53% of the natural stock rice and crop food. About 80% of the total fish production and 75% of the food for domestic use and export to another countries in the world. In the Mekong Delta, as I said, is a biggest agricultural and aquaculture cultivation of the Vietnam. These are the map of the rice and shrimp cultivation in the Mekong Delta based on the data since 2005-2010. In the left-hand side, you can see the map of the rice land in cultivation in almost the province in the Mekong Delta. While in the shrimp cultivation, mainly in the coastal area of the Mekong Delta. Due to the saline intrusion, about 1/3 of the area are affected by the saline intrusion. It affects to the coastal area mainly. In the rice production in the Mekong Delta, the use and rice production in the Mekong Delta increase from year to year. Every year, the many scientists try to apply, modify the variety, better farming technology, combined with the building some irrigation system and increase the number of dry crop use and the rice production of rice increase continuously. In the year 2013, we produce nearly 25 tons of the rice and export about 6.4 million tons of the meal rice in the world to the world, and the total export value nearly $3 billion. The Mekong Delta is very low and flat, and the average elevation is about 0.8 to 1.2 above the meter above the mean sea level, And the delta more than 750 kilometers in the coastal line. And so it is easy to affect by climate change and sea level rise, as well as the water boundary issue. There's many scientific evidence that the air temperature and the solar radiation have increased over past 10 years. Abnormal rainfall are more and more. In the early of the rainy season, the tendency of the rain to decrease. But in the end of the rainy season, the rainfall increase highly. The ground and shock water intrusion in the dry season increase, while the delta is at risk of the sinking due to the lack of the sediment, and the local people have attracts a lot of groundwater for their water supply, and amount of sediment flow to the Mekong stream reduced more than 50% if compared to the many years before. This is the problem, the big problem of the Mekong Delta in present time. Now, I would like to say something about the agricultural innovation policy in Vietnam. In the short, the Mekong Delta is facing three major challenges: climate change and sea level rise in global scale. The development of the hydropower dam in upstream of the Mekong River at a regional scale, and both the climate change and hydropower development are considered as the two external effects to the Mekong Delta. Concerning the internal impact, we also found that there's many land use change in the Mekong Delta due to the agricultural development, urbanization, industrialization, and other land use change, leading the delta degradation at the result of the internal impact. So, in present, the government of Vietnam had decided to change the food policy to reduce the rice production earlier and increase aquaculture production and increase the area of the fruit trees and other vegetable crop. The Vietnam government released Resolution 120 on sustainable and climate resilience development of the Mekong Delta. We say in short at Resolution 120. This resolution including the vision to the end of the century to the year 2010, 100, up still by the 2050, and we can find some viewpoint, strategies, orientation, and overall solution. In Resolution 120, we can find 4 main guiding viewpoints. First, strict sustainable development, 4 priorities based on the active adaptation, utilization of the potential and strength, transform challenges into opportunities for development. Second, change development tools shift from the most agricultural production of the mainly rice to development of the diversified agricultural industries to meet the market demand, shift from the quantity-based to the quality-based development. The third, respect natural laws and practical conditions, avoid violence, interfering in the nature. Select the model of the nature-based adaptation, environmental, sound, and sustainable development on the basis of the actively living with flood, package, and salt water. And the fourth, sustainable development of the Mekong Delta is one of the interests of the nation. The greater Mekong subdivision and international community and all the people and counts mobilized on the social classes, international partner and enterprise be involved in the development process. Many years before, we follow the traditional agriculture in mainly farmer in the Mekong Delta. They use a lot of the natural resources, mainly in land and water. They face high production cost, but receive a lot of agricultural value. In the farmer, we use a lot of the rural labor. And due to the use of the lot of chemical fertilizer, leading the environmental pollution, and we facing many risks and sustainable on the water resources, climate change, and a competitive market. Now we want to change to smart agricultural production by apply saving natural resources utilities. We try to reduce production cost and try to increase agricultural value. We thinking about how to upgrade the rural labor and protect environment. Everything should be put in sustainable development, not only in water resources, climate change, but also in the competitive market. But when we come to the traditional, to the smart agricultural production, the main question is, what should we do? Thinking about the smart agricultural innovation, we should thinking what model do we expect to have as an applicable smart agricultural innovation for the Mekong Delta. And all the people, not only the farmer, but also the scientists and policy maker should thinking about it. Now, I would like to say something about our idea about the applicable smart agricultural innovation. The model and smart agricultural innovation require a combination of the different parties that the farmer and agricultural sector cannot solve by them. There's a need for coordination and mutual support with the farmer in mind. And there's need to be link between the government, between the scientists, the business, donor, credit banker, and including the media sector. Parallel, research institute and the university are linkage center among the research and transferring the applicable of the science and technology progression to the farming community. For higher technology, the application remote sensing, GIS, blockchain, remote monitoring, and the solution for greenhouse gas emission, control the pollution, can make the agricultural sector and more sustainable. Now we had some discussion. We found that the transforming the traditional agricultural production that focus the higher output to the new model agricultural farming system with the high economic value in it, realities that rise in the Mekong Delta today. In the Mekong Delta, we found many smart initiatives being applied in agriculture and aquaculture production in order to increase the production efficiency and to match the market demand. We had many models about this. However, smart agricultural innovation ideas are still in the testing scale or pilot project, and applications stay at a small and inconsistent local scale. We think that it is necessary to have a multi-stakeholder linkage from the government policy, scientific and education forum, business sector, financial institutions, and all the support from all the social organizations to gradually rising the rural development and the farmer to get the new smart agricultural initiative into the practical field in sustainable way. Thank you very much for your attention. If you have any question, I'm willing to discuss with you. Thank you very much.
We thank you for the presentation from Dr. Tuan. And I'm seeing some questions coming out on the chart. I wonder if Dr. Tuan is available here for respond to those questions, or we'll wait until the end of the presentation, as I don't see Dr. Tuan in the audience. Well, okay, maybe we'll move on to the next speaker, which is Dr. Ajay Prahant, and his talk will be on sustainable agriculture, water management through Internet of Things. Dr. Ajay is the president and CEO of C2S2 Consulting Engineers, and he has over 3 decades of experience in planning, designing, and implementing infrastructure projects. He has been a consultant to the Planning Commission and a scientist in designing and modeling group of National Informatics Center, Government of India. He worked in CH2 Min Hill and Hawkru Jekko, India, as managing director, founder director, and managing director for DHV India, and as a head of the business and operations, the head of business and commercial, and of Fruitgrow general manager, and board members of RMS Incorporated in India. His key practice and research areas include technology intervention, mathematical modeling, oil and gas offshore engineering, river engineering, hydropower development, ports and maritime sustainable integrated water resources management, water and wastewater, waste to energy, climate resilience studies, policy, and governance. Dr. Ajay holds a master and a PhD in water resources management and engineering, is a member of the Board of Management KIS at University, a member of the National Committee to prepare a comprehensive roadmap for water management in India, surface water, and Flood Control and Dam Safety of Ministry of Shakti, Government of India. He is also a member of the CII National Committee on Water. Let's welcome Dr. Ajay's presentation. Yes, please load the video.
Good morning and welcome to the presentation on sustainable agriculture water management using Internet of Things in Punjab, India, a pilot study which has been carried out under the funding from the World Bank. And this is very important and challenging in terms of water management in India's agriculture sector. As you are aware that over 75% of water being used in agriculture sector. And mostly this water is being withdrawn from groundwater and surface water. And essentially we are talking about here is the use of groundwater using electricity for extracting this. And also we are trying to look at the food security in India. So therefore my presentation will address the nexus of food, energy in this case study. Let me just put a context to this presentation. Soon after the partition, most of the fertile and irrigated part of India went to the west, Pakistan, which is called Pakistan now. And therefore, India has to face the severe food crisis post-independence, 1947. And thereby India went on to the Green Revolution, which means that high-yield varieties of seeds, it is rice and wheat, and irrigations, infrastructures and irrigation, and also high-yield fertilizers. So, and if you look at in the current situation, due to the Green Revolution, the Punjab, which is the Indian part of Punjab, which produces a single state, almost 8 million tons of rice in 3 million hectares of land. And this is essentially over 90% of water being extracted from the ground using the electricity and the pumps. And if you look at that over the years, though there is a well laid out canal system is there, but farmers prefer to have independent without getting into irrigation scheduling, make them more independent in utilizing the groundwater. So over the years, the groundwater has been depleted. The per capita availability is also reduced, which also created a lot of other problems in the state of Punjab. And this is also due to the fact that the farmers in Punjab are not paying a single rupee towards electricity for using their groundwater extraction. Now, as you aware, the COP26 is just over, and India has committed to net zero emission by 2070. That also put India into another difficult situation in achieving the net zero, thereby to reduce also the CO2 and greenhouse gas reduction in all sectors. As you aware that rice cultivation, here I'm going to present this, has two large challenges, big challenges. One is rice is also produces, if you look at more CO2 and methane and greenhouse gas, and thereby also it uses water, which is like if you look at the water footprint, 1 kg of rice requires 3,000 liters of water, and thereby there is a concern that we need to ensure that crop water management for rice is being monitored and optimal used, and that also reduces further in standing water and thereby reducing also greenhouse gas. So these are some of the challenges in the rice. Thereby we went into a well-tested tools or the methodology of called alternate wetting and drying, and which has been tested in many parts of Asia. And as you all are aware that AW techniques reduces almost 30% of greenhouse gas, and thereby we thought let us use this. But there are some challenges as well with these techniques. And number one is knowledge intensive, which is required good understanding of soil moisture, thereby the crop water requirement, Labor intensive, that's also put many times the farmers not to go for it. Time intensive, as you require to really monitor, understand the demands, and thereby you also need to really spend quite a lot of time in that. The last one is high risk, because if the irrigation is not available when it is needed, then it could be also a serious problem in the productivity and yield as well. So these are the challenges. For challenges, looking at this challenge, we thought, why not automate this system using sensors and cloud-based Internet of Things to ensure that farmers is encouraged to use this system to look at the optimal use for the paddy cultivations. And if you look at the typical, from agronomy perspective, the vegetation, the rice, the transplantation to harvesting, there is sequence is a vegetative stage, a reproductive stage, as well as the harvesting stage. These are three phases where the rice grows, and a typical cycle is there. And thereby, if you look at the first graph, where it shows that what is the water requirement in the paddy, and how long we can the water can sustain. That means when you go down to the moisture level goes down to the -10 to 15. Until that time, the rice can still grow. From thereby, this agronomy science has put at also the growth versus water requirement, and we also follow this in our model. These are some of the sensors which use to ensure that AWS system is working on IoT mode, and it helps also farmer to adapt to this new technology. So soil moisture, to understand the soil moisture on the paddy field. Standing water level, that's one of the most important aspects to measure what should be the water level. The misnomer is that the farmer always think that more water in the paddy field always give higher productivity, which is again misnomer. That's why I showed you in the previous slide that water requirement and the growth of the paddy in different stages. The third one is rain gauge. That also required, if there is a rain happening, then irrigation probably can be put into the latter stage as and when it is required. Water flow meter is essential to monitor how much water is being extracted through pumps, and that will also give the volume of water being irrigated, utilized for the crop growth. The groundwater level monitor, this is also essential for understanding that how much we are extracting and what is the water level, what is the energy part in extracting from different levels, level the groundwater, and that's also to find out the consumption of electricity. Pump controller being used to ensure that the pumps are being controlled from the farmer's mobile phone app, where you can on and off based on the alerts or based on the instruction given from the cloud-based system. These are some of the sensors for your information, which we use for automating on the Internet of Things mode in the cloud system. And this is a map of Punjab. You can see this is next to, this is earlier before partition it was called East Punjab. The Punjab, which is now in Pakistan, it was West Punjab. So this is where in Indian part of the Punjab, and we looked at the three locations in Amritsar, Ludhiana, Batinda, three different regions, and we had 33 locations to test this model and efficacy to ensure there is a buy-in by farmers and the government. So 30 farmers were selected and 3 research stations were selected in these 3 different regions. And this is a typical irrigation scheduling system of rice, and this is again for different varieties. It has been fine-tuned based on the varieties of rice, paddy, and thereby the system is configured to deliver the water on demand. This is an algorithm which is used for rice, and this algorithm again it's been customized for different varieties of paddy to ensure that the farmers get this information based on the data already being collected, based on the varieties, based on the data of transplantations, based on the farmer's location, and all other information. And this is typical workflow of cloud server-based IoT for farmers. on AWD system. And this is how information moves around from the field to the server. From server, it goes to the control stations. From control station, it gives the information directly to the farmer through GSM, as well as other methods also. One of the important aspects that you need to educate and develop the farmers' understanding to the new system. Thereby, there are a lot of discussion, participation with the farmers, including the research officers, the farmers going to their site, ensuring that installation of AWD system is on a proper way to ensure that the signals are coming to the control stations. From control station, it goes to also server. This is typically the Kharif, which is called summer rainy season, where the farmers grow rice in the peak of the winter, peak of the summer, and the different varieties. And you can see the rate of transplantation, including soil type, to ensure the soil moisture, calibrations. This is typically one part of Ludhiana, where it shows that how the information comes from the system and based on different information received. And this is the standard graphs which have been presented. And once the system is done and harvesting is carried out properly, and measurement is also done meticulously to ensure that what is the volume of water use, what is the yield, and all. And this is part of the result, which you can see different varieties of different farmers. And then last column, you can see IoT-based system, what is the yield and what is in control stations. If you look at, I'll give you a summary sheet of that. So if you look at the findings, it shows that an average 4% improvement in yield, and it also helps in reducing 70% of irrigation in the particular variety, we're looking at PR varieties. On an average, 5% improvement in the yield and 10% irrigation what's in Pusa. Pusa basmati is a popular variety which is being grown in Punjab, and essentially majority part of that is also being exported out. With the outcome is essentially we have successfully automated the AWD system into sensor-based IoT, cloud-based IoT, and also helps in managing the crop water as based on the demand of different crops. It also helps in managing the groundwater exploitation. It means earlier when the pumps were running, the farmer typically switch it on and goes back home. And then, the volume of water which has been extracted is always more than what is required, because there was no control, no measurement. It was based on the assumption or the standard thing, this much water should have in the paddy field as a standing water during the standing crop. So it also helps in increase in crop yield. This is essential due to the control system, because you are utilizing the actual crop water, and based on the agronomy and the science. It also helps based on the soil type. It also helps in reducing the funding of water in the field. That also reduces the methane, although we have not measured actually how much methane is being generated or reduced in that, but this is the next study we are going to do. Reduction in energy use essentially, because as I mentioned in the beginning that the energy is free in Punjab, there the farmers do not really care of using energy meticulously. So the pumps are on, and it gives more water, it injects more energy, and thereby it is not really good for the crop, not for the state. So it is detrimental to all of them. So therefore, IoT model successfully piloted this rice crop. We also did for a wheat, but I am concentrating here only on the rice part. Also, our idea is essentially once it's successful, now the next phase is essential going to certain districts where the farmers are already signed up, and then it will go on the statewide. That is how it is going to be implemented after the state. The other aspect, as I mentioned, that it's education, capacity building, awareness, adaptation. Thereby, training and capacity was important aspect. We also do, it's a continuous process. It also helps the farmer to build their understanding. Now, benefits government in many ways, as you mentioned, that it helps in reducing or extracting the groundwater. It helps in saving energy. It helps in monitor the what irrigation systems. It also helps in managing the crop yield versus other logistics aspects in the system. That's for the government. It also benefit farmer because farmer is getting more yield, utilizing less electricity. Is also having a less input in terms of physical labor because he can monitor and manage all irrigation systems during including in fertilizers during the growth cycle. He can also do when he need to do apply the fertilizers or maybe pesticides at different rates. It also helps through this IoT-based systems. The benefit is immense. As you know, there's two other benefits. One is the community benefit. It allows the entire the community of farming community to also the government to save huge expenses in on electricity, labor charges. It also helps the farmers for a better understanding of the crop water management. Environmental, it's again immense because it also helps in reducing the groundwater. It also reduces the carbon footprint, water consumption, which I said that 1 liter at 1 kilo price for 3,000. That also going to be. It also helps in greenhouse gas emission reduction. So those are the number of benefits. As you see that it helps the farmers. It helps also to achieve this zero emission by 2070. Also, we have been trying to use the renewable energy as much as possible because 50% of the renewable energies by 2050 is going to be in India. It's going to be from renewable part, and thereby irrigation sector, the agriculture sector is going to lead in this way by utilizing the renewables. With this, I thank you all, but thank you for giving me this opportunity to speak at this international seminar. Thank you very much.
Thank you very much, Dr. Ajay. This is excellent presentation. It's a well done, well planned, well executed projects. Congratulations. If you look at the chart, there are from Puro Singh, and one comment indicating that your presentation was very good. And then the other was a question asking if that presentation will be at the AIT's Symposium website. Are you attending to answer those questions?
Yes, if you want me right away, I can do that.
Okay. I think all the presentation file will be uploaded somewhere at the AIT's conference websites. I believe so. And if there are other additional questions, please don't hesitate to send in your questions in chat. I thank you very much, Dr. Ajay.
Thank you.
And I just see Dr. Leon Tuan online. Dr. Tuan, are you there?
Yeah, I'm here, yeah.
Okay, if you have time from now for the next, and look at the chart, there are 3 questions and 1 comment on your presentation. So take a look at, and I'll come back for you to answer those questions after another presentation, okay? Please consider those questions.
Yeah.
All right, this is our 3rd and the last presentation for this this morning. And the speaker was originally Dr. Ganesh, but then he has some conflict. So we have Dr. Victor Marco Ferrels as a replacement. Dr. Victor obtained his PhD in aquatic biosciences at the University of Tokyo in 2016. He is currently the Associate Professor at the College of Fisheries and Ocean Sciences of the University of Philippines, Visayas, where he trains students and researchers in formulating science-based solutions for the needs of the fishery industry. He has spearheaded several projects funded by the Department of Science and Technology related to microalgal production systems, as well as Aquaculture Mechanization. He is also currently leading the establishment of Philippine Center with Visaya satellite facility with the aim of utilizing omics technology to aid research in the fields of fisheries and aquatic science. His main research interest focuses on functional genetics and biochemistry, with other studies ranging from aquaculture engineering or algal molecular biology, biochemistry, and synthetic biology. So let me welcome Dr. Victor, and please load up his presentation file.
Good morning, ladies and gentlemen. First of all, I would like to thank the organizing committee of the AIT 50th Governing Council Committee for giving us this opportunity to share some of the work that we've been doing here at the University of the Philippines Visayas, in particular in relation to mechanization of selected aspects of aquaculture, wherein we try to find a balance for sustainable production. So before going into what we've actually been doing, I would just like to discuss a few points related to agriculture 4.0, or what we would say agriculture during the fourth industrial revolution. Now, agriculture in the fourth industrial revolution in general is about breakthroughs in emerging technologies in fields such as robotics, AI, nanotech, quantum technology or quantum computing, biotech, the Internet of Things, decentralized consensus, fifth generation wireless technologies or 5Gs, 3D printing, and autonomous vehicles, just to name a few. Now, when we talk about agriculture in relation to the fourth industrial revolution, this refers to combined internal and external interactions of farming operations, offering digital information at all farm sectors and processes. Another term that we would usually want to use for agriculture 4.0 would be precision farming. And in the pictures here, you see the use of biotech, drones, and even robotics in a lot of operations in some aspects of agriculture nowadays. Now, when we talk about agriculture and digital farming figures, what's very interesting to point out is because of the Internet of Things, it has the potential to increase yields of agriculture productivity by as much as 70%, projected by 2050. It's also been shown that nowadays, around 70 to 80% of new farm equipment is used or has a component for precision agriculture. This could be in the form of a global positioning system, or even just sensors that allow us to gather as much data as possible from harvest, sowing, and all other aspects of agriculture. Another aspect is that in the near future, there will be around 27 billion devices by 2024. That's not too far along. That's around 3 years from now. And out of that 27 billion devices, around 225 million will be used for agriculture. Now, the importance in all of these particular innovations comes in the form of being able to, one aspect is being able to reduce crop losses. So it's been shown that 90% of all crop losses are because of weather. And this crop damage could actually be reduced by as much as 25% by using predictive weather modeling and precision agriculture techniques. Now, with all the background on precision agriculture, we here at the University of the Philippines Visayas kind of thought now, it paints a very good picture for agriculture, but for the Philippines, where are we in all of this? And in actuality, despite all the developments in agriculture in terms of using GPS and a lot of sensors and robotics to assist in agricultural processes, the truth on the ground here in the Philippines is that a lot of our agricultural processes are still very backward. So this is one of the more common machines that you would see in a lot of farmlands here in the Philippines. It's a hand tractor, and at this point in time, development in agriculture in the Philippines is still very far from what we dream of being part of the fourth industrial revolution. These are just figures. These are already dated figures showing the level of farm mechanization back in 1990. And as you can see, the more developed countries like Japan, Korea, and China have invested a significant amount of horsepower per hectare when it comes to agriculture. And when it comes to the Philippines, we've been lagging behind at less than 1 horsepower per hectare. Now, in more recent data, despite considerable progress, for example, for the Philippines, it could still be shown that we lag significantly behind a lot of our neighbors when it comes to the use of mechanization and horsepower per hectare. Previously in 1990, it was less than 1. Here it's a little bit just over 1 horsepower per hectare. And this reflects in, for example, the price of rice that we have here in the Philippines. In the Philippines, the price of rice or the production cost of rice is at around 11 pesos per kilogram. Thailand has significantly reduced this to around 8.4 pesos per kilogram because of the significant amount of mechanization that they've also been implementing in rice agriculture. Vietnam, on the other hand, is a very good example, although we weren't able to get data in terms of the level of mechanization for Vietnam. The production cost for rice is at around 5.6 pesos per kilogram. So it just shows the significant contribution of being able to mechanize aspects of agriculture in bringing down production costs. Now, the Philippines is not or has not really, lacked in terms of effort in trying to implement mechanization of aspects in agriculture and even fisheries. This is evident in some of the laws that have been passed, like Republic Act number 10601 or the Agriculture and Fisheries Mechanization laws. Despite this, there is still an evident lack of implementation of mechanization at the farm level. That's where, for example, other government agencies like the Department of Science and Technology have been trying to implement research projects such as the Smarter Approaches to Reinvigorate Agriculture as an Industry, or SARAI. They've actually been trying to implement more advanced technologies in rice agriculture, actually by the use of drones and other aspects for mechanization to improve really rice production. Now, despite all this, we have to admit to ourselves that in all comparing the progress of the Philippines to our neighbors, technically the Philippines is still playing catch up. So we ask ourselves, why should we mechanize? Well, first and foremost, it has really been proven that mechanization has been positively correlated with farm productivity. This is evident in the productivity of the farms in our neighboring countries here in Southeast Asia. Now, one other aspect why, for example, some farmers are hesitant to go for mechanization is that the reasoning is that mechanization is capital intensive. But if we look at the progress of technology, be it in agriculture, biotech, for instance, even in genomics, you've seen that because of the progress of development of technology, it has also driven down the cost of machinery prices since the 1970s all the way up to the present. And it has also been shown here in the Philippines that the cost of labor is actually one of the biggest contributors to the high cost of production, and not necessarily any attempts for mechanization. Another factor that keeps our farmers from trying to implement mechanization here in the Philippines is that they've been saying that mechanization could be a culprit to increased environmental degradation. And one answer for this is a concept known as conservation agriculture, wherein it's an approach to managing agroecosystems for improved and sustained productivity, increased profits, and food security, while at the same time preserving and enhancing the resource base of the environment. And a lot of countries have been implementing mechanizations or machines that are geared towards what we call conservation agriculture. So these are just a few examples of these. Now, another factor why a lot of people are still hesitant to really mechanize at the farm level is that they use the argument that mechanization will take away jobs from our farmers. But then again, we have to look at the numbers that we have here in the Philippines. For instance, in terms of farm employment over the past several years, we've seen a gradual decline in the number of farmers per million people here in the Philippines. When in fact, because of this decline, the average age of farmers here in the Philippines is 57. So the farming sector here in the Philippines is a really aging population. And we also see that it's compounded actually by the increasing amount of wages or peso, the amount of wage that is necessary for farmers per day. It means that it adds cost. The amount of labor adds cost to the production as well. So with this in mind, we've clearly established why mechanization is really important for us to really increase productivity here in the Philippines. So why should we mechanize? First, it improves productivity for food security and safety. Next is technically we are able to implement sustainable systems here in agriculture, and it allows us to minimize the environmental impact of this human activity. Furthermore, it also allows us to adapt to socio-economic changes in terms of the demographics of the farming sector nowadays. Now, with this in mind, I would like to discuss some aspects of mechanization when it comes to aquaculture. Now, a good example or a good model for aquaculture mechanization is Norway. So I'm pretty sure a lot of you throughout Southeast Asia and through our neighbors in Asia would go to supermarkets today and you would easily see, or it's easy to purchase, for example, salmon coming from Norway. And one of the reasons why they were able to come up with such large productions of salmon for them to be able to export this is because of the implementation of advanced technologies in terms of cage aquaculture and also in terms of being able to mechanize the feeding aspects for salmon aquaculture. So it's the progress of Norway is very evident in terms of the increase in the production of salmon aquaculture output over the past decades, as well as being the major being a major exporter of farmed salmon all throughout. They have a stake of more than 50% actually in total global aquaculture production of salmon. Now, when it comes to the production of aquaculture in the Philippines, we've also seen a steady increase because actually a lot of the seafood that is being consumed in the Philippines nowadays are being sourced from aquaculture, and there's a shift from capture fisheries going into aquaculture. So we see the opportunity in aquaculture here in the Philippines. But despite the opportunity that aquaculture proposes, it has also spawned several problems. In the case of cage aquaculture, for instance, it has been identified as one of the culprits for increased marine pollution along coastlines. This is mainly because of the high stocking densities, but more importantly, it's because of the feed that is wasted when you use manual feeding. Studies have shown that around up to 60 to 70% of feed is actually wasted when you use sinking pellets and manual feeding. Another problem of, for example, intensive cage aquaculture here in the Philippines is that when we use manual feeding, it results in very high feed conversion ratios, which also results in a very wide distribution of fish sizes at harvest. This would give you a variation of prices for your harvest, and sometimes most of your harvest would be dominated by the smaller fish, meaning that you get less value for the amount of feed that you put into at the end of your culture period. But these the challenges have also provided us with opportunities to implement new technologies. So based on the number of cage aquaculture systems we have here in the Philippines, we've seen that it comprises around 27% of the total volume of aquaculture here in the Philippines, and it's still actually growing. So because of this, it provides us with a good opportunity to come up with new technologies to support the growth of this particular sector further. So with that in mind, Here at the University of the Philippines, we've tried to come up with technologies to support this particular expansion. One of the things that we've been working on is the remotely operated automatic bottom feeder. So it's one of our innovations to try to address issues on feeding efficiency, labor needs, and both the environmental impact of cage aquaculture. So we initially developed this particular technology through the Department of Science and Technology funding through a project called Enhancement of Milkfish Culture Operations through Mechanization. So if we look at some of the common fish that we culture here in the Philippines, such as milkfish and tilapia, when we look at the mouth structure of these particular fish, these are actually mid-water feeding fish, meaning they feed at the middle of the water. So we realized that in order to really maximize this particular aspect of the culture species, we have to adapt the way we feed these fish. That's why what we wanted to do is come up with a bottom feeding mechanism using floating pellets. So first, it's suited to the feeding habits of the cultured fish, namely milkfish and tilapia. It also maximizes the water column as a feeding area as compared to just feeding it at the surface. Finally, it also allows fish even access to feeds, resulting in more uniform sizes. And so far, the data that we've been getting from the use of our automatic bottom feeder has been good. We've been able to drive down the feed conversion ratio from 2.5 to around 1.8, which is considerable improvement in the efficiency of how fish are able to utilize the feeds. At the same time, in terms of size distribution, when we compare it to our manual feeding experiments, we used to get very small fish sizes previously, but with the implementation of our automatic bottom feeder, we were able to eliminate the extra small size fishes and get a considerable larger amount of medium to large and even jumbo fish at harvest. Aside from that, we wanted the technology to be environmentally conscious as well. Aside from being efficient and reducing the feed that is being wasted, we tried to design it in such a way that it could be solar powered. This allows us to deploy this particular technology offshore, allowing us to really use this even in deep water cages.
So just to wrap up my talk, I would just like to summarize it in these 3 points. First and foremost is that increased productivity coupled with sustainable practices can be achieved through the development and, more importantly, the use of new technologies. Now, despite the resistance to adopting new technologies, data has clearly shown that it is feasible from a scientific perspective. But in my opinion, somehow, it's more important that it also shows that it's somehow a necessity from a socio-economic standpoint. And finally, Philippine aquaculture can further expand and support targets for both food security and economic development through the appropriate adoption of emerging technologies. With that, I would like to end my talk, and I would like to thank again the organizers for giving us this opportunity to share some of the work that we've been doing. Thank you and good morning.
Thank you very much, Victor. Very good, excellent. You do have one question in chart. You may want to get it, and then I'll come back for you to reply to that question. So let me go back to the first speaker, Dr. Tuan. And just to remind everyone that Dr. Tuan's presentation topic was on sustainable development for the Mekong Delta, River Delta. So there are a question from Kiwis, from Ray Ramos, from and Puro Singh for Dr. Tuan. So Dr. Tuan, are you ready to
I'm ready.
Exchange opinions and discuss with those people who have questions for you?
Yeah, thank you very much. Thank you all the question. This is very interesting. I think that any integrated solution for the development of the Delta, like the Mekong Delta, is very important to note. And in that, all related sector have cross-supporting integration. The solution of the Mitra Banga increase need to reference and pilot testing is Mekong Delta in a combination with our local knowledge and real condition. I think it's very necessary. Currently, as I know, the government of Vietnam is conducting an integrated planning for economic and social development in the Mekong Delta region in the period 2020 and 2030, and a vision to the year 2050, in which a solution of all stakeholders are considered and selected their idea. We think that we have to carefully selection for the long-term sustainable development in the Mekong Delta. Concerning the question of the Mr. Ray Ramos about my opinion about the conservation agriculture in a small, in a smart approach farming. As I understood, conservation agriculture is a farming system that prevent the loss of the arable land and who the integrated land. It promotes maintenance of a permanent soil cover, medium soil disturber, and diversification of plant species. I think in the Mekong Delta, not only our university, Cần University, and all the research institute are active research and support the sustainable agricultural development in the Mekong Delta region, including the solution to the conservation agriculture, organic agriculture, green agriculture, and reduce greenhouse gas emission, so on. However, the trial and application are still small, and we continue carefully to monitor, evaluate, and refine the solution before graduate expanding in the last area. Involve the question of the Mr. Kiwi. How would you suggest to involve the all stakeholders to participate in your proposal solution? Most qualified is social positive involvement. I think in all application of the agricultural solution in the Mekong Delta, we open on the different opinion of the stakeholder, from the technical, economic to the social and policy maker. And everyone knows farmer in the Mekong Delta, to their, although they contribute a lot of the food to Vietnam as export to the world. However, most of them are still poor, low educated, and a lack of support of infrastructure. So we, together with the government of Vietnam and many non-government organizations, are actively supporting their agricultural transformation every step of the way. And so the participants of the social positive involvement are really needed. And concerning the discussion of the Mr. Singh, with the two questions, what would be the reason of a smart agriculture to be still in a local small scale? And the second, what is the impact of the Mekong River regulation with the series of the dam in the Mekong Delta agriculture in at a time when we are getting impact of the climate change? On the hand, introduce the smart technology. I think is the first question. The main reason for the smart agriculture is still happen on a small scale, and currently in the Mekong Delta region still lack an integrated plan. I can say it's a master plan with we are still many unpredictable issues such as the climate change, impact of the upstream hydropower, and challenger of the agricultural market. In addition, applying smart agriculture is still often expensive as compared to the income of the local people. So we have to careful to develop it and on a small scale. And we try to review on the pilot project before to apply in the larger scale. And as we know, the Mekong upstream hydropower development in the Mekong Delta is changing the flow regime of the Mekong River in the downstream region, including the reduction of the alluvium, of sediment, and fish stock, and change ecosystem. This issue forced the people in the Mekong Delta to change their agricultural production strategy toward the reduced rice cultivation, because as you know, rice cultivation need a lot of the water, a lot of land, and the value of the rice is still low in the international and internal market. We are graduate transitioning the develop the package and the saltwater agriculture, because the effect of the climate change and sea level rise, the saline intrusion come to the delta deeper and deeper, and we also thinking about all the food tree and suitable vegetable crop. However, the solution for the planet, we also thinking about how to store more water in the lowland and make the more flood absorption in the province are being promoted in order to solution some impact of the change of the hydrological condition due to the hydropower dam operation in the upstream. Thank you very much.
Thank you very much, Dr. Thun. Obviously, the hydropower development projects are quite controversial among various countries, a lot of examples. I really think that your work to change the food policy in response to those crises is a very smart move. I totally agree with your work. Okay, thank you so much. We have Dr. RJ, and you make a presentation on the Internet of Things. There's one more comment coming in from Jin Wang. Can you take a look at that comment or questions? And then for Victor, there are two comments or questions. You may want to take a look later after Dr. Wei. RJ has made a response to it.
Yeah, Professor Ru, I think there's no. This was just on a comment. There is no question, and I saw that he was just talking about that using of technology, Internet of Things, and automations is going to take India into a long way in solving some of the crises. I think that was a comment which well received.
Yeah. Yeah, is Jim Wang here in the audience? Or you have any comments or any questions that that you may want to add it to it, or you want to do it at the panel discussion later? Okay, Victor, go ahead and say what do you have for those two other questions?
Okay,
from Ramos and from Kiwis.
Okay. Good morning, everyone. Thank you. In terms, so I'll first try to answer questions from Ray Ramos. Sir Ramos asked that what's the implications of what they call this mechanizing in terms of fuel of the fuel that is to be consumed by these farming machineries. Now, if you look at the data, for instance, in terms of project, I think it's more of a balance of sustainability, because right now we're very concerned about climate change and the effect of using fossil fuels to really push forward a lot of our industries. But when you look at agriculture, even for the more advanced, what they call this agriculture countries, or the countries that implement a lot of mechanization in their agriculture aspects, the range of the amount of
horsepower that they use per hectare would just be around, at this point in time, probably in 2021, it would be probably top off at around 25 horsepower per hectare. And that's a very, very small contribution when you try to compare it to other industries. For instance, a single car that has a 1.5-liter engine would be running at around 99 horsepower, occupying a very smaller space compared to 1 hectare. That is for the horsepower dedicated for agriculture. But one good thing about that is, given the relatively lower amount of horsepower or energy that you need to mechanize aspects of agriculture, and the progress that we've been seeing in terms of electric technology, obviously right now it's really focused on electric cars, but we've seen also the development of larger machineries that are electric driven. So we've seen, for example, the development of larger vehicles that are purely electric. And I believe that this could easily be translated to tractors and other machineries that we use in agriculture. Case in point, for instance, when it comes to irrigation, the Department of Science and Technology here in the Philippines has actually started implementing solar-powered pumping stations for the several irrigation systems here across the Philippines. Now, my opinion about mechanization and how it somehow affects soil health. I mentioned earlier in the presentation that we have this aspect or this concept called as conservation agriculture, wherein although you use machineries, these are machineries that are designed not necessarily to what they call this, drastically affect the health of soil, taking into consideration all the information that has been gathered on how particular tilling and other agricultural processes affect soil quality. So when it comes to mechanization, it's always a balance between how one could make things more efficient and at the same time reduce its impact in terms of the environment. And how can we really encourage our local farmers or change their mindset about mechanization? And local farmers also think that mechanization might also reduce local employment. So as I mentioned earlier, a lot of our farmers, the demographic of the farming sector here in the Philippines is a very aging population. And how I see it is that given all the developments that we could implement in terms of what they call this, not only mechanizing agriculture, but really just making agriculture a smarter industry. The way I see it is we have to encourage the younger generation to actually go into agriculture, because they are the ones who I believe would be more savvy, more adaptable to utilizing new technologies, especially when it comes to utilizing the Internet of Things, as what Dr. AJ presented earlier. So one aspect that I was thinking of is really to get, in order for local farmers to adopt new technologies, is really to change their mindset, but also to try to get the younger generation of Filipinos and probably all across Southeast Asia to really go into farming and see it as not only something that is necessary for food security, but something that will also provide economic development. So I hope those answers the questions from Mr. Ray Ramos. In terms of a question from Mr. Kiwi Saliwarga, okay, what kind of pellet do we use for the bottom feeder? Actually, the floating pellets that we use for the bottom feeding machine is actually just your commercial floating pellets. What we did when we were trying to develop this is try to come up with mechanisms that would minimize the breakage of these floating pellets when it passes through the machine. Because we noticed that, for example, even for your commercial floating pellets, if you try to use mechanisms that are very, what they call this, that cause very strong shearing strengths, it damages the pellets, and in effect, it also affects the ability of the pellets to float up. So we try to implement to use particular mechanisms that would reduce mechanical damage to the floating pellets that the commercial floating pellets that we use. And the mechanism that we've been using, we've been experimenting with a lot. Some of the things that we've seen that are better at reducing, for example, the mechanical shearing of our floating pellets would be similar to a Venturi system, if you're familiar with that particular aspect. And I think the last question is, which factor is more dominant in reducing the feeding ratio or feed conversion ratio when automatic bottom feeding system is implemented, the automatic mechanism or the bottom location? When it comes to actually reducing food conversion ratios, it's more of the automatic aspect, because we've also played with the automation of even just surface feeding. And what we've seen when it comes to feeding fish is that you could feed less feed at a time, but at higher frequencies throughout the day. It means that basically your fish is feeding more frequently throughout the day, instead of just giving bulk feeds at certain times or at limited, maybe 3 to 5 times a day, as compared to, well, the automatic bottom feeder that allows us to provide the feed up to 12 and even 15 times out of the day. By spreading out the frequency of when we are able to feed that, and obviously by using an automated machine, it makes it much cheaper as compared to relying on manual labor. We've seen the feed conversion ratio being dropped because of that. The advantage of using a bottom feeder actually comes in terms of being able to come up with more even sizes of the fishes when you harvest this. Because even if you get to spread out the frequency of feeding throughout the day, for example, if you use manual feeding and floating pellets, the surface area of your cage or even a fish pond limits the number of fish that could eat at a time, because your surface area is much more limited. But when you think about the entire water column and then start utilizing bottom feeding, utilizing what they call this floating pellets, you make the feeding area, instead of a 2D from the surface, it's actually a 3-dimensional feeding area for your fish. And that allows you to really what they call this really get more even sizes of fish, because of the more even access they have to the feeds as well. So I hope those answer the questions that have been posted. Yeah.
Great, Victor. They did a very good job. I hope the audience are happy about listening to your comments and answer to their questions. Very helpful. And I think we have about 30 minutes for this section. So let's move on with the panel discussion. Now, this is, we have 2 panelists who will make about 5 minutes of conversation presentation to us. And then we are all open to everyone who have questions, who have comments. Please send those in chat. So we will go through those one at a time. Okay, now the first panelist is Dr. Kiwa Aliwaka. Are you there, Kiwi?
Yes.
Okay, let me read it very quickly about your excellence bio. You're the Chief Executive Officer of UMG Myanmar and the founder of the UMG Ideal Lab, an Indonesia-based corporation venture capital and venture builder. You have your bachelor degree in industrial engineering from the Institute of Technology, Indonesia, and a master degree in engineering from AITAA, I think. And then another master in system dynamics at MIT Sloan School of Management. You're currently completing your PhD. Congratulations, hope you will get through, in agriculture from a university in Indonesia. Now, I think that the thing that impressed us is that you're seeing the impressive growth of Southeast Asia technology industry. So you then initiated the founding of the UMG Ideal Lab. Its business line are being divided into 2 parts. One is as an incubator in Myanmar that helps startups begin their business, and a corporate the venture capital and venture building in Indonesia that has initiated startup with seed funding investment. You're helping a lot of young people. The firm is also investing in technology-based startup in Thailand, Malaysia, Singapore, and China. A great job. So you have about 5 minutes to make any comments that you wish to contribute to this section.
Thank you.
David?
Thank you, Professor Jay. Yeah. First of all, I would like to thank the three contributors. They have made a good presentation, good case. And I would like to maybe share my own experience on implementation of technology 4.0 in Indonesia. When I start entering the doctorate degree for agriculture in University of Gajah Mada, the question that I asked, why our farmers still poor? Yeah. Why other farmers in other countries are already better off? The first initial things that I recognized is, oh, maybe because of technology, maybe because expertise. I'm damn wrong. I'm damn wrong. It's not about the expertise. They are no better than us. They know better the climate change. They know better their soil. They know better their commodity than us. Second, technology. Of course, they do not know the technology, but technology is only a fraction for their success. So at the time, I already founded the company called PT MSMB. Yeah. We try to implement the technology to farmer, but we failed miserably at that time. So it takes us 2 years to really think what is important. How can we help the farmer change? So Professor Tuan mentioned very briefly, and that is the essence. Yeah. The integrated stakeholder play together to support and make sure it is success. So the MSMEs try to work with the bank, with the financial institutions, with the NGO, with the government, with the farmer, with other stakeholder of supply of the agri input, and also the off-taker. So we combine this and make it the pilot project, and then try to see some fruit, but still not consistent, because expert system in our technology system is only particular area and only particular commodities. And farmer has so many commodities in so many area and different climates. So it's an ongoing process, and it needs to invest and then to go. Now we already just established the soil analyzer to check the NPK, just NPK for each area and also for the commodity. So we need to add more commodity. We need to add more expert system. We need to understand more about the climate change and also social impact. That is my feedback from all of three is nearly the same. But I'm most interested also from Dr. Victor. Yeah, it's we have the technology of integrated technology for the fisheries. But the bottom feeding interests me. Bottom feeding. So I now start to imagine how is the mechanism of bottom feeding? How can the feed spread outside? Because the fish is not only in one area, it's spread outside. If you put in the bottom, the pressure is so high to go abroad. Otherwise, the size of the fish is not uniform. Yeah, it's also a big problem. So I would like to understand more about this one. But all of you have made great contributions on your field and in your area. Congratulations.
That's all? Okay,
Yeah,
thank you, Kiwi.
Yes.
Yeah. Thank you very much. I think it's interesting for business development from your conversations. Okay, let me go ahead and introduce our second panelist. Is Dr. Haya Ullah here? Dr. Haya Ullah? Doesn't look like.
If not available, can I ask? Can I ask the presenter?
Yes.
The next people not. So, Professor Tuan, you have made the solutions, proposed solution. Have you really made the implementation in the area, and then how big impact, and what is the insight from your implementations? Yeah. For Dr. Anja, I think you have made very specific item, but my question first, is it solving the problem? Because you are solving the problem using the underground water. We also have limited underground water. That is actually is shooting our own leg. Yeah. Is there any other solution that you think for the future, like making water from the air? Yeah. I think we can make water from the air. Yeah. So that is the challenge for you and for Dr. Victor. That's my question. That one. What is the mechanism to spread and to make sure that the fish is uniform size in growing? Thank you. You're on mute, Dr. Tuan, Professor Tuan.
Dr. Tuan, you need to. Okay.
Thank you. Just as our consideration in the Mekong Delta, when we develop any farming system, we try to apply in a different scale and different location in the Mekong Delta. In the Mekong Delta, we had 3 parts. The upper part is a flooding area, and the coastal part is the place affected by the saline intrusion, and the middle combined in 2 different water conditions. And when we introduce any new farming system, we try to develop in each ecosystem area, and we try to collect all the data and make analysis. We organize many workshops in the field or in the auditorium, and we receive many comments about it, and we try to adjust the farming system before we expand to another place. And when we expand to another place, we have to continue to consider the real condition to apply or not, because it's dependent on many aspects, like the knowledge of the farmer. For example, when we change the rye cultivation to the rye and shrimp cultivation, we should train the farmer to train the farmer how to change from the agricultural production to aquaculture, and we also consider the infrastructure about this, and all the conditions, including the market condition. When we introduce a new vegetable or the new fish, how about the market accept or not? Yeah, of course, we have to carefully to thinking about it, because we don't want to fail when we apply with the farmer. Yeah, there are very vulnerability with many factors like climate change, the market condition, and the social condition, and so on. Besides, we also work with the local government and the central government. How about the policy support them or not? If there is some limit or barrier about the policy. We should get the government had to change the policy to support the farmer. Thank you.
Very good explanation. I get the insight from you. Thank you very much, Professor Tuan.
Any of our audience, if you have any comments, any thoughts, any questions, please do not hesitate to address to our panelists or our speakers. Please do that. Dr. Tuan, I have a very simple question about your strategy of diversify the production of foods. For example, maybe reducing the rice productions, but then the supply demand would tell us once you reduce your supply, your demand may not be met, and then the price will go up. So would that you will see those potential problems in the future, because many of the Asian peoples are eating a lot of rice, and it's an essential product for that.
Yeah, in our strategy for agricultural production in the Mekong Delta, we had to reduce the rice, because many years before, the rice priority is the policy of the government to make sure about the food security. But the problem is the rice price is very low, and the farmer, although they export, they produce a lot of the rice, including the rice export, but they're still poor. So we had to we still keep the rice production, but the limit is in a suitable area. We are thinking about it and calculation how much the rice production is needed for the Mekong Delta and for the whole Vietnam and export partly. But we had to try to increase the use and combine with the other agricultural or aquaculture to modify the life condition of the farmer, suitable with the infrastructure and all the development in the Mekong Delta. It's not so easy.
Okay.
We had to careful go step by step.
Yeah. I have visited the country a couple of times, so hopefully we'll see you in the future. Thank you very much. Any other comment from the audience? I have one quick question for Dr. RJ. You mentioned that you have 4% yield improvement, and then about 17% water saving from the effort that you implemented. Are you seeing the 4% is the ideal, the maximum, or you still have potential that you can go up to maybe 10% yield improvements? And then the other second question is that do you monitor the greenhouse gas emission and see how the percentage of the greenhouse gas emission reduction that you may be expected to be?
Yeah, Professor Yu, thank you very much. Well, actually, this is a first pilot project with 30 progressive farmers, and you need to be scale up, using a district scale or maybe whole the state level. Required a great amount of training, capacity building of the farmers to get used to the automations, and also to understand, because the fear factor is very high. They don't want to fail in irrigating their crop at the time. They still do not believe many times the science of agronomy, that crop water requirement for paddy is so. It's not like that you have to hold 10 centimeter of water, standing water in a rice field. Yeah, so that's that's an experiment, but we did actually for wheat, which is if you look at the cropping systems in Punjab, essentially it is rice and wheat. So immediately after rice harvesting, so we could see that the farmers are coming forward, and this is in we actually improved to 6%, 5.8 to 6%. I'm sure you're right, actually, but I'm not sure 10% yield would be so high, but 10%, I think it's a big number. But water saving, certainly from 17%, it can go up to 20-25% with implementation. But biggest factor is, Prasu, that we, Punjab state, only spend almost $1.5 billion US free power, you know? And that is where we are trying to really, you know, bring in that how to reduce the pumping and electricity uses by controlling the rationing through the IoT system to the farmers, giving also confidence of that productivity is not going to be hampered. So that's the whole idea.
I think that's very interesting project. Very good. Yeah. It's challenging too. Do we have any other comments from the audience to the panel? Or you, may I ask the panel, we have one, to give maybe 2-3 minutes summarizing what you think about the conversation we had today. So Kiwi, you want to say something?
No. I'm waiting for Dr. Victor to reply.
Oh, okay. Dr. Victor, are you replying him?
Yeah.
Okay,
yeah.
go ahead.
With regards to the concern about what they call this, the mechanism for releasing it at the bottom, we've also done modeling in terms of how, for example, your pellets, your floating pellets would interact throughout the whole water column. And we've also tried to do documentation on how these interact. For water is a very, what they call this, it's a thick medium when you compare it to, let's say, air. So if you release it at the bottom, the tendency of a pellet is not really to just float up straight. And because of the shape of the pellets that we've been using here in aquaculture, it's not totally round, because the way that what you call this floating pellets are produced for aquaculture or feeds in general, it gives you a more cylindrical shape. So it has a tendency to be less hydrodynamic, and it provides more drag. So we've tried what they call this, designing different bottom releasing mechanisms, or spreaders actually. And we've seen that even if our spreader has a diameter of around 10 centimeters, after floating 1 meter up, the spread of the feeds would be around would be in a radius of around 0.7 to 1 meters, and that also continues to increase as the depth increases. And for our the average depth that we use for our for our net cages here in the Philippines, we've seen that for our around 2 to 3 meter deep cages that we use, it allows by releasing it at the bottom, even with a 10 centimeter radius, it allows us to spread it over. By the time it reaches the surface, it would be a radius of around 3 to 4 meters already. And that the general, for example, radius or area of the cages is around 5 by 5 meters already. So it's already a considerable spread of feeds. At the same time, when we did video documentation, what's good about being able to feed at the middle is that the movement of fish actually also adds to the spread of the feeds while it's going up. So more or less, compared to just releasing floating pellets at the surface and then utilizing the whole water column, it in effect provides a certain level of increase in terms of the access to feeds of the fish in your fish cages. Yeah, that's it. And I saw a comment from I think Dr. Puru Singh in the chat box, also commenting on what Sir Kiwis mentioned, and he said that he is of the view that continuous defragmentation of land parcels in a number of developing countries is causing a major hurdle in mechanized agriculture. And I have a tendency to agree with this. We've been seeing this in the Philippines, for instance, because a lot of the agricultural lands are being converted into residential areas. So it really fragments, for example, areas for agriculture. But for example, for mechanization to be more efficient in terms of the amount you invest in for it to operate continuously on large scale. If your farmlands are discontinuous, either physical, this is from the thought of farmlands being discontinuous physically. Yeah, that's one of the hurdles I think that is we've also been seeing here in the Philippines in terms of adopting mechanization in terms of really large farm machineries, and that's why it's also a challenge for engineers to come up with better solutions for farmlands that are much smaller. It still provides a certain level of assistance in terms of mechanizing aspects, but it's not so much what they call this capital intensive, and that would require large tracts of land for you to operate machineries at a more cost-effective level. So yeah, those are my thoughts on the comment I just saw in the chat box.
Okay, very good.
Very good.
Anything else? Well, I really learned a lot from the speakers and panelists and the questions. We had Dr. Tuan talk about the policy issues and the demonstration project from RG, and then the Victor talk about the concept of mechanizations, and Kiwi was helping us to understand a lot of business development things. So that's all. I think we run up with very good coverage for many aspects of this. I do appreciate, thank you very much for the speaker, the panelists, and the audience for being here. I don't know if I can ask the staff supporting from AIT that we can take a picture for all of us. I don't know if that is doable.
Yes, maybe maybe
that
ask
is very
everybody.
much doable.
Yeah.
Everybody should show their best face.
Show the camera, yes.
Yeah.
Sunday morning with their Sunday morning gloves.
So if everybody turn on the video, then the AIT supporting team will take us a picture for us.
And on the count of 3, we can take pictures. There are 2 screens. So yeah, I'll count and then I'll take pictures, and then also request my colleagues to take pictures. So 1, 2, 3.
You look so serious. Smile.
Yeah. Page number 2. Many people are not yet open their cameras. Please. Win. Why are you not? Right? Yeah. Please, everybody.
Yeah, we'll take one more picture.
Yes.
So on the count of 3,
Alice,
so everybody smile.
Hiding.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, we are not counting in Thai.
Yeah.
We are not counting in Thai because I think there are a lot of non-Thais also over here. So yeah, on the count of 3, 1, 2, 3.
Good, hi, ba.
Thank you.
Thank you very much, and I really enjoy
much.
seeing everyone, and wish everybody healthy and productive in the future. I see you again, and welcome to North Carolina. If you should come this way, let me know, and I'll try to be as much as see you as much as possible. Okay. Thank you. Bye bye.
Thank you.
Thank you. Good job, Jay. Good job.
See you all in the next session starting at 10. See you all in the next session starting at 10.
Yep. Okay. So we close officially this session. Please move to the next technical session 3. You can use.
Thank you very much, sir.
Thank you and good.
Thank you. Thank you.